In this video, we're going to be looking at the graph of cotangent. It's going to be very similar to the graph of tangent. In fact, we're going to be talking about it in much the same way. In this case, a couple things to jot down. We want to make sure we understand that cotangent. Let me get my marker here. I want to make sure that we understand cotangent. Remember, cotangent is just the reciprocal of tangent. So if tangent is sine over cosine, cotangent has to be cosine over sine, which also means on the unit circle it is x divided by y. Everything is just flipped around when it comes to tangent. Okay, lots of relationships there. So as we go through and we think about this, again, think about it the same way we did with tangent. If cosine was 0, what would that make cotangent? Well, if this is 0, 0 divided by anything is 0, so cotangent would also be 0. Cosine is 0 at pi over 2 and 3 pi over 2. Then what happens when sine is 0? When sine is 0, this entire fraction is undefined. That means a vertical asymptote. So cotangent will have a vertical asymptote wherever sine is 0. And that happens at the y-axis at 0 degrees or 0 radians, and also at pi. Okay, so we're going to have some different vertical asymptotes and x-intercepts than tangent does, but we're still thinking through it the same way, basically. And then think through on the unit circle, what is that ratio of x divided by y? So in the first quadrant, both are positive. We should expect cotangent to be positive there. In the second quadrant, y is positive, x is negative. That fraction would get negative right here. Really the same thing we did with tangent. So this would be another positive, because in the third quadrant, from pi radians to 3 pi over 2 radians, they're both x and y are negative. That means that fraction that we're creating is positive, and over here we get negative. And so very much the same way we did with tangent, if we just think through this enough, this must start up high, go through this x-intercept, and then go down along the vertical asymptote. Then it starts again up high here, goes down through here. That's what we should see as we animate this picture here. It's going to be in kind of a neon green. See that it's just as we go around the unit circle, that seems to be the pattern that it's following. I want to get this down on our notes, so I need to erase what we already put down. There we go. Okay, I'm going to quick pause it and make sure my graph looks halfway decent before I show it to you. So hold on a sec. Okay, so what you should see in my very messy graph here are vertical asymptotes at 0, pi, and 2 pi. X-intercepts then at pi over 2 and 3 pi over 2. And then we just kind of connect in purple. The purple is actually the graph here, but we connect in purple the way things should work with those x-intercepts and those vertical asymptotes. A typical question that, again, we could ask for any of these four graphs that we're looking at in this section is just to figure out where these functions actually equal a certain value. In this case, we need to use our calculator. So I want you to imagine maybe what this should look like first. We know we're going to look at between 3 pi over 2 and 2 pi. So in this section right here, I want to know, where does cotangent equal negative 0.6? Well, in this part right here, from 3 pi over 2 to 2 pi, it is negative. So to figure this out graphically, you would graph cotangent of x, and remember that's just 1 over tangent of x, which, well, I guess, yeah, you could enter it into your calculator that way. You could also, as we're going to lose part of our graph here, you could also graph cosine over sine. That would certainly work as well. But in your window settings, you've already, basically what you're going to do is graph cotangent. You're going to graph negative 0.6 into y2. y1 will be whatever you represent with cotangent. y2 would be negative 0.6. Your window settings, you could go just from -1 to +1. It fits this particular y value there, so that could work for y. For x values, they're actually telling you what to do. Just type in 3 pi over 2 and 2 pi for your x, min, and max. Make sure you're set in radian mode, and you should be able to see two graphs connecting pretty easily. So I'm not going to do a whole lot with this question. I'm going to let you guys kind of figure that out. What I do want you to do is try to come back to class with an answer. Do your best to graph cotangent of x, to graph -0.6, to set your window settings appropriately to make sure you're in radian mode, and figure out what answer you think this question, or what solution this question should have.